you. Yeah, so my name is Maria Pimenta Ocampo. I'm a research associate working for EBRI, and today I want to share with you the Biochar Cleantech Accelerator project. So I will start first to introduce you to EBRI, and then I will cover the project itself. So for those who don't know us, EBRI stands for Energy and Bioproduct Research Institute. We've been researching in bioenergy, biochar, and bioproducts for quite a while, since the 70s. And we specialize in thermal conversion of organic waste streams. And we have an extensive experience working with different industries and government bodies. And we also provide expertise in feasibility and life cycle studies. It's a great work environment, and our labs are always buzzing with postgraduate students and postdocs. And it's quite amusing to see new feedstocks being analyzed and processed over here. And the number of projects that we are involved with keeps growing as new students come in. And again, we continuously seek to engage staff and students through different projects and placements. So that's us. Now, as to our specific project, Aston University has been awarded a funding for the Biochar Clean Tech Accelerator. You may also hear it as a clean tech project, and this is to be developed as part of the West Midlands Innovation Accelerator. So this was first announced in the government 2022 labeling up white paper. And so the West Midlands Innovate Accelerator commenced in 2023 in May. And this was and is funded through a share fund from Innovate UK and to be distributed between 3 different regional innovation accelerators. So one is just one of them. And this is to cover for 2 years. So this means that our project has already started and we are actually midway towards the end. And the deadline for the funding is May 2025. So just to give you the concept, the context. So the aim of the Innovation Accelerator include to accelerating, of course, the regional engineering research and development, reinforcing the UK innovation from the West Midlands by enabling businesses to develop new products, processes, and services. And we do this by creating our own regional industrial cluster. Okay, so as you see, this is very much applied technology to the real world. That's why we collaborate also with the Aston Business School. In other words, the project aims to commercialize knowledge and our university research capabilities, not only for the benefit of the environment, but also for the regional economy. And we seek to open new domestic and export markets to help to rebuild engineering and manufacturing in the region. So last year we delivered several webinars around biochar and also carbon accounting for local small and medium businesses. And this is us. We are quite a multidisciplinary team, and our last workshop in November, we were explaining, and this is the pictures that you can see here, the great potential of pyrolysis as a way for waste management and to look as well for different partners to commercialize the biochar, but also the other related bioproducts. And we continue to do this in different events. So if you ever come across us in any of the events, please do come and say hi, because we are always happy to talk to you. But yeah, so we firmly believe in pyrolysis as one of the routes for decarbonization, and we are dedicated constantly to prove that the technology aligns with the sustainability development goals that you may be more than familiar with. And let's dive in the project then. So the Biochar and Sustainability Materials Demonstrator. There is plenty of names for this project, but you will listen to them as we progress. So yeah, Aston University, in conjunction with local industrial partners, this is Combined and Future Energy, among others, developed this pyrolysis unit that is able to transform organic materials such as sawdust and fallen and deceased trees, and also agricultural straw, among others, into hopefully commercially valuable products such as biochar, but also pyrolysis liquids and pyrolysis gas. The unit is located at Birmingham City Council Nursery. So this is the place where if you so the Commonwealth Games, where all of the plants came from, all of those that were populating Birmingham City, they come from this nursery. And we just have our unit just outside there. We are sharing the space with them. And this is our unit right here. So the unit consists in 3 different containers. One is for storage, another is the control room, and another is the one that contains all of our valuable equipment. So the auger reactor is just there, and it's called the Conklin, and the rest of the equipment. So the idea is for it to work in batches at the moment, so it's not continuous. And this is because we are treating different feedstocks that we receive from different companies that we have collaborations ongoing with. And we are looking to provide eventually the heat and cooling to the nearby horticultural polytunnels, which you can see on that picture, I hope, which are owned by the Birmingham City Council. And I have a little video for you. Hopefully it will be able to run, but you will see all of the areas that I just mentioned, and hopefully a little bit more of the reactor. Yeah, it works.
Can you increase the volume, Maria?
Sorry?
Can you increase the volume somehow of the video? Okay.
What the project is doing is capturing the wood before it rots down and then processing it so that the carbon is actually sealed into a material which is called biochar. And that biochar then can be put into the ground under the planting of new trees. So the new trees planted in biochar grow more quickly and they also absorb more carbon.
We've developed a reactor system that we call the Biochar that actually takes material, heats it to temperatures approaching 600 degrees Celsius, breaks them down into base materials, solid, liquid and gas. We then take the vapor, condense it and gain oil. And the oils could be used in any sorts of bioproducts, be they fuel or bioplastics, for example. The gas can be used for heating and, in fact, for cooling. And the char itself is a very, very valuable product used in the agricultural and organics industry for plant growth and the like.
We're looking at what options we've got of managing that volume of timber. Using it for biochar is just one of those options that we're looking at.
It's important to actually, we will actually be using it as a training exercise for students from us and giving them an introduction into working in a production sort of environment, and knowledge for their studies and also possibly for their thesis in the future.
Because biochar's got so many interesting and different applications, we're working with lots of local companies across the Greater Birmingham and Solihull area to see how those companies can use this material to decarbonise their supply chain, which gives them lots of advantages in the marketplace and also helps them with their business generally.
All right. I hope that was good. The volume at the end? Yeah?
Yeah, it was better.
All right. Well, Well, as you heard in the video, we are able to run at 2 different modes. The typical one that you will see always is the one that produces mainly the biochar, and then all the rest is flare. We can obviously do that, but at the moment, what we are more interested in is to run with our condensing unit or condensation unit on. So this allows us to remove the condensable phase or fraction from the non-condensable. So in this case, the pyrolysis gas that is removed from there is cleaner to burn, and it's actually easier for us to manage. And then on the other hand, we have a mixture of pyrolysis liquid, which is basically a mixture of the pyrolysis oils and the aqueous phase. The aqueous phase you may have heard in the literature or even seen online as commercialized as wood vinegar. It has plenty of names. This is one of the things that we have to come up with a fixed name for it, because it truly gets a bit tricky after a while. But it's what we call aqueous phase among us. It will be wood vinegar depending on the feedstock, right? But basically it's the aqueous fraction that contains acetic acid and phenolics and other organics in lower quantities, and some of the nutrients that were captured through the condensation process. But we are constantly analyzing every product. We do that here at EBRI, and we analyze the composition, but also assess the energy and mass balance of each one of the runs. So we are gathering an extensive library on these activities at the moment. So for the biochar, we contrast the properties against the standards that we have available at the moment. I heard that there is another one that is in development, so we may add that one to the list very soon. But the ones that we are looking at most closely is the EPC, and now with the World Biochar certificate, well, that one as well. But yeah, that's what we are doing at the moment. And also we are looking at assessing the sustainability of the whole process. That's actually my job. And basically all of the data that we have processed, we are using as a source for the in inventory. So we are collecting all of that, and we aim to register eventually the technology, meaning the unit, through Pure Earth. So for this, we have to calculate, of course, the carbon capture potential. We are using the methodology that they have available in their website. I'm not sure if you are going to get this presentation afterwards, but I'm sure you can find that in Pure Earth's website if you are keen to have a look at that. It's a very interesting read for those that are not familiar with it. But basically, we are calculating the potential stored carbon over a window of 100 years, because that's the one that they suggest. That's the period of time that they suggest. We are using these equations provided by them. I think it's very interesting that they only use the soil temperature as a way of modifying the permanence of the char in the soil, not the organic matter, for example, but just a thought. I wanted to drop it there. But yeah, this is the way that we are proceeding, following the methodology that is already stated. And for the rest, we have to deduct the emissions produced during the feedstock procurement, during the process itself, and we are also accounting for the production of the unit, which some people I've seen don't actually account for, and also for the emissions related to the use of the biochar, or the end of use in this case. And also the transportation related to these activities. And we do this using CIMA-PRO. So with CIMA-PRO, we are following, of course, the life cycle assessment methodology stated by the ISO 14044. And again, we are using CIMA-PRO for this and creating the life cycle inventory, which took ages, but we have that now. And we are also considering using other tools such as Grid. Especially in America, they are quite keen to use that for some reason. But we are using mainly CIMA-PRO and, of course, Excel. But yeah, so as I mentioned before, we are assessing different covering different applications of the materials. So we are, of course, looking at the agricultural applications. So that would be for the biochar and also the aqueous phase. So for the biochar, I'm sure we are all here familiar with the benefits of using it as a soil enhancer and also as alternative growing media to endorse peat replacement. But with the aqueous phase, we are looking at potential applications as an alternative fertilizer, but also as possible herbicide or as a source of chemicals, alternative source of chemicals. Here at Aston, we don't really have a soil department, so I have conducted a few modest spot trials myself to basically respond to those claims, but it will be quite beneficial for us to have that done through a third party. And well, the results we are collecting now, the data from them still, and will be published as soon as we have them. But on in all, they just confirm what the literature says. We also have several case studies, so applications of our products in real world. So the biochar that we produced last year, for example, was used in the Chelsea Flower Show arrangement that Cofton presented. So as I said, we are located at Cofton Nursery, so we provided them with some biochar that they used to mix with their compost, which was peat-free. And this was used to create flower or sedum arrangement to make the rooftop that they produced for the Chelsea Flower Show. And they got an award, so that was very exciting. We have also used the biochar to plant trees, thanks with the collaboration that we have with Kia, and that happened in Birmingham in a street on an area that is called Hall Green. So we had planted several lime trees with the biochar. We use 2 different types of biochar, and we also have some control trees, so no biochar added with them. In this case, the biochar was also added with the compost, and we are closely monitoring the progress. We actually have to do the measurements in a couple of weeks, and because this was done in November last year as well. And just anecdotically, we also use the biochar that we have like spare and our own plant arrangement. So this was a terrarium that we created for the workshop, and you can see also biochar in our pots, basically populating the whole office and the communal areas. And just recently, we had another event organized this time by the Aston Environmental and Sustainability Team and Aston Students Union. And in this case, the students were collaborating to plant all of the flowers that the gardeners had grown. And we used the chance to apply biochar to 10 of them. So this was mainly to engage the students and to tell them about the benefits of using biochar and well, about pyrolysis and waste management. But yeah, again, this is mainly for engagement, but since we had the chance, we actually did mark the sunflowers that we had added the biochar to. So we will keep an eye on them in the upcoming months. And they are right in front of our building. So, but yeah. As I mentioned before, we are also looking at other applications, not only as soil or agricultural applications. So we are closely testing its uses of not only the biochar but also the other materials as for construction materials, for concrete, but also composites, for road production, so as a binder, or also for filtering the water that comes out of the highways. For 3D printing, that's something that we are also looking at. And given the antifungal effect of the aqueous phase, we're also keen to explore the use of the wood vinegar or the aqueous phase as a wood preservative. Of course, the filtration using biochar as a filter for water, but also for the air if we manage to make an activated carbon out of it. Maybe also exploring the possibility of creating graphite. And one thing that we are actually spending a lot of time in is to extract invaluable chemicals or components. So as I mentioned, we do have the capabilities of doing the full characterization of all of the materials. And we are doing this not only with the char, but also with the aqueous phase and the pyrolysis liquids and also the gas. So to extract valuable chemicals from them that could be commercialized and potentially cover some niche applications. So I'm using this opportunity to call for collaboration. If you think you like to collaborate with us in the Biochar Tech Accelerator in the form of we're not really looking at the moment to create or to publish. That's not our main goal. Our main goal is to show the potential applications of these materials in the real world. So quite practical approaches. So if you have any capabilities that you think you could, collaborate with us to basically create this data so we can support these claims, we were more than happy to collaborate with you. Just drop us an email to the email address that you find in the screen. And before leaving, I wanted to show you something that we've been working on. We have released already some months ago the first biochar guide. Irene wrote this. It's one of our colleagues, and she gathered extensive amount of biochar producers and suppliers and retort cleaning producers as well, and biochar consultants over the UK. Those that wanted to be featured in the guide are there for you to look at. Like they have a summary with all the contact details. So I think it's a brilliant piece of work that she did, and she's working at the moment on the second edition. So we have more industrial partners or biochar producers that want to be featured there. So you have that available online. If you are not able to click here or you don't get the copy, please just write Biochar Guide every, and it will be free to download for you. Just have to fill a form, but I thought I will give you that. But yeah, that's us. If you have any questions, please feel free to do so. Let's see what we can answer.
Thank you very much, Maria. Very nice presentation, and quite a lot that you're doing in Esten at the moment.
Yeah.
So the floor is open for questions. If you have any, write them into the chat or unmute yourself, whatever is more favorable for you. I would have a question, which would be, are you also looking at the economics of the projects?
Yeah, that's one of the main pillars for sure. Yeah, not only the sustainability in terms of emissions, but yeah, we do have that as a main question for sure. Yeah, and it will depend on the products that we decide to go for.
And do you already see one that is very profitable and everyone should do?
Not at the moment, because we are still learning on the go. Biochar, of course, there is an extensive market. And for some reason, apparently, there is a shortage of biochar, or that's what we heard. So the market is there. It's just for the alternative products. That's the one that maybe need to be created or refined, because there are plenty of products in the market at the moment, especially the wood vinegar, that is not even regulated, or is regulated, but people are not really following REACH before launching their product to market. So we are obviously learning on the go in that respect. But yeah, it's actually very lucrative, the aqueous phase of wood vinegar.
You got a question from Ben Lichtenstein.
Sure.
So he says 3D printing applications are super exciting. Can you talk briefly about the current future work that you are doing there?
I'm afraid I can't, but I also agree it's very exciting, and we are not we obviously not the first one to do that. There is plenty of work done before that, and there is also this case study that we always like to look at. That is the Audi building that actually featured the biochar, which was 3D printed over there. We are working with the department here and collaborating with them, but it's still very early on in this respect. But that's what I can say at the moment. Anything that we will finished, it will be published in our website. So that's what I would refer you to go for. But always feel free to send us an email, and then once we can share, then we will share.
Okay, I can also add that we are working in the Biomark project on 3D printing biodegradable plastics made with biochar. So there's something out there already, but this is also not published yet.
Yeah, it's the same thing.
Um,
I wish I could share everything.
and so if you say you are looking for collaboration partners, is the collaboration, just to clarify this, you're looking for applications of or new business models that want to get a hand on biochar and test this, or?
So if you look at the literature, there is already a good amount of work for most of the applications that I mentioned. It's just that we actually want to see if the materials that we have produced ourselves match the claims of those research. So it will be a matter of conducting a short experiment, and something between a couple of months to 3 months will be ideal, just because of the deadline that we have mainly. We're looking to expand it, but it's better to finish the project with the highest amount of information that we can gather. So it will be a short experiment, again, looking mainly at practical applications, because sometimes when we dive into research, we can get lost in lots of different questions and we get excited, but commercial wise, sometimes some of those areas that we're exploring are not really feasible or not really applicable yet. So something that could be commercialized in high quantities, that's something that we are looking at. But yeah, for example, something like an incubation experiment will be obviously very much welcome. Microbial reaction to biochar applications, that would be nice. And we can always talk about how we can collaborate in that respect.
And that's so probably we are a bit at the end of the time, but you
Mhm.
got a question from Dan Range in the chat that you are happy to answer about a potential collaboration there. But from my side, thank you very much, Maria.